Okay, looks like I'm live. Good evening, as it is in the United States. I'm Peter VK3YE, and just in case people are around, I thought I'd do a quick live video transmission, Q&A session. If you've seen the previous ones I've done, just ask me anything. And yeah, greetings to John, K8JGG, and glad that you enjoy my books. Lighting's very poor. Yeah, we'll see if problem is that it's not particularly. I'm relying on natural light, and it's a fairly cloudy, overcast day, so not particularly good. I do have a portable light, but its orientation is not. I don't have a cord long enough to stretch it to the camera. Yeah, it will mainly be talking and answering questions, so the lighting doesn't matter so much. But what I'll do, we can move the angle of the camera somewhat, and that might like a little bit of a better improvement. So we'll just do that now. We have 6 people on board, which is great. There's a bit of glare on the screen, so I'll eventually get a better lighting system. It just hasn't been much of a priority. So yeah, glad that you enjoy hand-carried QRP antennas. Yeah. Reason why I'd focus on portable operating is that although it's wet and miserable here in VK3, Northern Hemisphere is coming into their summer, and there's also a field day in the US. So yeah, hopefully people now have only got a week or 2 to go. So yeah, yeah, so now is the right time to be getting set up with portable equipment and antennas. So yeah, thought I'd do a session just in case people wanted to ask me anything about those. VK1JH, dish antennas to build for 2-meter portable operating. No, generally speaking, dishes are used for higher frequencies, microwave bands. Dishes on 2 meters would be pretty big and probably not portable. You know, so yeah, mainly. So for 2-meter portable operating, I would suggest just anywhere between a 4 and 6 element Yagi is quite easily carried by hand for 2 meters. Ham Radio DX, good antenna for those interested in SOTA work across all HF bands. Easiest is to, I find, with SOTA work, of course, depends on what's at the top of the hill. Are you able to tie your pole to something, or is it just bare rock with nothing to tie your antenna to? Because supporting the antenna is a really big thing. I would tend to use something if it only needs a single pole. That's easier than something that requires 2 poles. An end-fed wire about 20 meters long or a little bit more is good. That will work very well on 40 meters. 40 meters is the main band that most SOTA people here in VK use. Although if you wanted to operate on 80 meters, then I'd make the antenna a bit longer. Half wavelength, like 40 meters would be better, but then you're probably going to need a second pole and some means of supporting it. For 20, a 20-meter long piece of wire will work on 20 meters as well. You can just use a small L-match antenna coupler, like the type described in hand-carried QRP antennas. However, if you wanted to make 20 meters as your main band of operating, then something like a portable dipole would be fine. You could even make it In fact, a good overall soda antenna is a link dipole. There's one of my videos that talks about it. In this case, you could just get a 40-meter full-size dipole and cut the wire at various points along it to and have alligator clips so you can short out your wire. You have the full length in for 40 meters and you have only half the wire length in on 20 meters, and you could have different tapping points for different bands. Gets a bit unwieldy, but and then you have to lower the antenna every time you want to change bands. You can do that fairly easy with a fishing pole. But yeah, that gives you good performance if you want, you know, a basic horizontal dipole for SOTA. Yeah, basically end-fed wire is good. Especially with an L-match antenna coupler where you can get multiple bands. A link dipole is very popular. Verticals are less so. You might have to set up a ground plane. Yeah, cheap fishing poles are great. You might have to set up a ground plane, and that can be tricky, unless there's, say, a metal fence that you can tap into, but you might not get much of that near summits. If you're only wanting to operate on a single band, then that's a bit easier. You can have something like a coax-fed dipole. Otherwise, you might want to go for something that's open wire feed line and balanced antenna coupler. And fine on the Wolf River coil. I don't know the MFJ 1979. And cheap fishing poles, yeah, great. I don't know how we lived without them, but yeah, really good for SOTA. You might have to think about how you're going to support it. I don't do a lot of SOTA myself. I've probably done more national park than SOTA, and a lot more operating by the beach. And for that to support the squid pole, there's usually either a fence where you can tie it to, or you can use a sand stake, hammer it in. Make sure you bring a hammer or mallet and a meter or so of angle aluminium, hammer it in, and use a some sort of Velcro tape to hold it on. And fine on the 16 feet stainless antenna. Well, that would make it 5 meters long, so that would make it a half wavelength on 10 meters, and a quarter wavelength on 20 meters. And you could use an antenna coupler to cover some of the other bands. On 40 meters, it would be a bit of a struggle. It would be a bit too short. Although you could, as I've done in recent videos, you could add a capacitance hat, 10 meters or so of wire across the top, adds a bit of capacitance, and that can make short vertical antennas work very well. And that would even work on, I've had great results on 40 meters. You can use a loading coil. With the loading coil, they may be sharp in tuning. You might have to use an alligator clip to select your frequencies, and it might be a bit sharp. Whereas if you have a T antenna, let's say 5 meters up or 16 feet and 10 meters across, then you could just use an L-match antenna coupler at the bottom, and that can get you on multiple bands, including 40 meters, where it's surprisingly efficient, and even on 80 meters. Although I did a video, I think it was about a month ago, where I had some great results with that. The collar approach sounds a lot easier than some sort of tapping point. But it's still a bit of a luxury to be able to change your antennas, everything at the bottom, just by adjusting an antenna coupler, which you can do with a T style of antenna. Of course, helps if you've got a good ground. I'm a bit lucky being over salt water, or if there's a pier to clip onto, or if you've got a counterpoise that you can set up. If you've just turned on, we've got 8 people viewing. The time should be convenient for evening in the on the west coast of the states, and maybe some of the central states. A bit late for those on the east, and those in Europe, well, you should all be fast asleep. Telescopic pool cleaner poles, they can work well. You're listening to a Q&A session, and I'm Peter VK3YE. So ask me anything, especially about portable antennas and QRP. The book that you're seeing, if you're curious, these are paperback copies of 2 of the books I've written. Minimum QRP, which talks all about low power, and hand-carried QRP antennas, more specialized for antennas. Research and build. Did you ever build a regen receiver? Yeah, I have built several of them, both valve and solid state. Have a look on my video channel. Just search VK3YE and regenerative receiver. They work surprisingly well, especially for casual shortwave listening. They may not be so good under strong signal conditions. If you've got transmitters nearby, they can be overloaded. But yeah, especially for, they can still hear DX CW signals. So a regen receiver is quite a fun little project. You can just build one with 2 field effect transistors or similar, and if you have plug-in coils, you can make them for the AM broadcast band and get shortwave frequencies as well. So yeah, definitely a lot of fun. They can cover a wide shortwave spectrum, several megahertz per band. Though some of my regen receivers I've built maybe about a year or 2 ago use ceramic resonators. And if you can get them in the amateur bands, then they can be quite stable and cover a section of the amateur band in a regen receiver, which is quite novel. But yeah, there are different types of regen receivers, depending on the feedback arrangement. Some of them have a separate coil that provides feedback, usually in the drain circuit of the field effect transistor. Others have a tapping in the source of the FET, where it's tapped down the coil, and that provides a bit of feedback. So yeah, if you do build a regen, make sure you put a video on YouTube, as yeah, they're quite fascinating. 7 megahertz crystals, yeah, availability can vary. One place I have used for crystals, I don't think they sell ceramic resonators, but crystals, is Expanded Spectrum Systems. I think it's N4ESS, and they've got quite attractive prices. Show and tell of the other book covers. Fortunately, I don't have paperback versions of the other books. I can show you inside some of the books I've got here. Now, I'll show and tell other than book covers. Yeah, I haven't gathered a lot on my table, but if you, I might go away and get something, and I'll be back in a moment. Okay, I've just violated the rules of good theatre, and that's never to leave a blank stage. But I do have a gathering of bits and pieces that we can we'll have a look at a bit later on. And K9LUC, yeah, good to have you on. We've got 12 people listening, so if you've just joined us, then welcome. And glad that we're being watched in Siberia. The RV9MD. What you're seeing here, it's full of dust, but this is quite a this is a project I built. Well, Well, this is a car radio underneath it, just an AM only car radio. Australia was quite late in getting FM broadcasting. We only got a few stations starting from the mid to late 1970s, and and then there were some commercial stations started up around 1980. But it was really only, even as late as the mid to late 80s, AM was probably still dominant. Anyway, this car radio, I'm using it as a tunable IF. And the dusty thing you see on top of it is actually a converter for 2 meters. I'll try and get some better light. That's better. And this converter allows, oh, there's the speaker behind it, allows reception of 2 meters FM signals. This is a crystal oscillator and one transistor. It taps off the frequency a bit higher up of a harmonic of that. Then there's a frequency multiplier, and that gives a frequency around, let's say, 145 megahertz and high to WB9JIA. And that provides a local oscillator signal to the converter, which is a single transistor, quite an old transistor, I think a BF115. So it's not even a FET. And the incoming signal from here on 146, 147 megahertz comes into this coil. It mixes with the beat note provided here at about 145, 146 megahertz from this crystal oscillator or multiple thereof. And the IF, it's converted down to around 1 megahertz. So you can get a tuning range of a 1 megahertz tuning range. It's converting it. So you're doing all your tuning on the car radio. Yeah, it's not the most sensitive of receivers, but I have been able to receive 2 meter FM repeaters from about 30 kilometers distance. So this was a very crude way of receiving FM signals on 2 meters. Now, the reception isn't quite as clear as with a purpose-built FM receiver because you are slope detecting. So you have to tune off to one side and receive the signal, and then you can hear people chatting on repeaters. So that's a project I just thought I'd bring to the bench. And if you've just turned on, you've got Peter VK3YE, and I'm doing a live stream where you can ask me anything. And Orion, yeah, glad that you like the project here. Haven't turned it on for a while. Now here's something else, a little more skier. I have built I have done a video on this. I'll try and orient so you can see more clearly what the parts are. It's just built on a block of wood. I really want to learn to build a mixer. Now, a mixer can be very simple. There's diode mixers that require 4 diodes, like 1N4148, and you also need a couple of broadband ferrite toroids. A lot of that's widely documented on the web. They are quite good form types of mixers for use in direct conversion receivers or as balanced modulators in transmitters. If you want to build an SSB transmitter. They're also good in converters. So yeah, you basically need some ferrite, a couple of ferrite toroids, and you wind some wire over the toroids to make a broadband transformer. To do that, you twist the wire. I think you need 3 lengths of wire from memory, wrap about, and you have it about 30 centimeters or so long. You twist, you use an electric drill or something to make a twisted lot of wire, and then you wind that through your ferrite toroid, something like a T50-43, and that provides your broadband transformer, and then you connect that up to diodes, and you might have 2 broadband transformers in there. So that is a basic diode mixer circuit. Another way you can get mixers is using a chip like an NE602. That type of mixer actually has a bit of gain in it, but that's basically a mixer in a chip as well as an oscillator, which could be handy for some projects like converters. Other mixers just use transistors and field effect transistors particularly, and just need a few resistors and capacitors and some tuned circuits, and away you go. So yeah, mixers are no big deal. Yeah, this Morse keyer here, it uses bits of brass that the hardware shops sell. They're actually used to wrap around electrical wires and nail into walls. So if you want to anchor wires, then you use these brass strips. But I've used 3 of them to form the contacts of this keyer paddle. So one of them is connected to the common connection, one to the dots where it forms a switch like that, and the other to the dashes. And that's taken out to a stereo socket, which connects to your transceiver, which has got all the circuitry in for the timing circuitry for the Morse keyer. So that's you can send at reasonable speeds, maybe 17, 18 words a minute, maybe 20, with a little keyer like this built on a block of wood. Very simple, only takes 10 minutes or so to build. I've done a video on it, which you can look up. And yeah, the NE602, yeah, it's not the best as far as dynamic range goes. But it's fine unless you live near really strong broadcast station or next door to an amateur who is running a kilowatt. Yeah, you might need a bit of front end attenuation for it, but yeah, people have worked what it works okay. Even some of the Elecraft QRP rigs, I think they use NE602s, so they can't be that bad. Yeah, John Greniff of 144 megahertz Yagi. Done a couple of videos on it. There's a popular design by DL6WU. What do I think about Ashar's Antrino? I've only had a quick look at the thing on the website, but it looks like an awesome project. Looks like it'll be a really useful general purpose thing. Antenna analyzer, it's something that I haven't had so far. I'm very tempted actually to get one. And I don't know of the other things it's got in there. Maybe it's got a RF signal generator or something, but it could be handy for some other RF tests. So that's something to look out for. I was looking at it on his website today. He was saying that it's going to be available sometime from this month. As far as the 144 megahertz vertical, yeah, it is probably easier, but you aren't getting as much gain. Like even a 6-element Yagi on 2 meters, that will have 10 dB gain. So that basically is as good as running 100 watts if you've got a 10 watt transmitter, whereas the vertical would have similar gain to a dipole, unless you go for really long verticals like collinears, where you can get a bit of gain. So yeah, 144 megahertz Yagi. You can start off with something even simpler, like even 2 or 3 elements. 2 elements from the point of view of antenna gain for the amount of weight that you're carrying. 2 or 3 elements on 2 meters is vastly better than a single dipole. You might even get 1.5 to 2 times the distance. And if you look at the area that you're covering, areas like the squared of your distance, you might double your coverage. So for say a VHF field day, then a small beam is definitely very, very worthwhile. And greetings to Argentina. And yeah, we've got 12 on, which is good. If you've just turned on, I'm Peter VK3YE, and you can ask me anything. I should also mention there's I write a blog called The Daily Antenna. There's one post each day on an antenna-related topic. But yeah, if you want something quick to read on antennas, dailyantenna.blogspot.com. And yeah, there's a post every day, and there's usually only a couple of paragraphs of writing, and then there's 3 or 4 links to if you want to find out further. What's the lowest power I've made a contact with? Well, I've definitely made contacts with 20 milliwatts on SSB on 40 meters, and that was with VK2, so that would have been about 700 or 800 kilometers distance. Because you'll find that with really low power, certain distances are really optimum for different bands. If you're running, let's say 100 watts, you've got a lot of cases where your path might not be optimum, but you'll still get through. Whereas when you're down to the milliwatts range, you're only really working stations that have an optimum path, right distance, or they've got very low noise levels, which can really help as well. Yeah, and congratulations, 500 milliwatts, 1,000 miles on 20 meters. Yeah, 20 can be quite a difficult band for QRP, but for the single hop type of contacts, especially when there's at times when there isn't much QRM from DX stations further away, then it can work quite well. Not quite 2 milliwatts, 20 milliwatts. Yeah, no, 7 megahertz very easily works well up to 1,000 kilometers. And I've made contacts pedestrian mobile with magnetic loops up to about 3,000 kilometers on 40 meters. So that was with 5 watts. So 7 megahertz is good up to about 1,000 kilometers. And not too bad up to about 2,500 to 3,000. Beyond that, it gets difficult, and then bands like 14 megahertz can come into their own. Binaural direct conversion receivers, haven't turned mine on for ages yet, but a fun project, and a mag loop would be quite interesting listening with it. I'm just trying to think, have I worked lower than 20 milliwatts? I've done occasional whisper tests where I've dropped the power less, but no, I don't think I've gone any lower than 20 milliwatts. Some other notable QRP things. I had a contact on 6 meters with a homebrew CW transmitter on, it was crystal controlled, it was 3 transistors, half a watt, and I worked a guy in Japan. Although this was in about 1992, where the solar peak was pretty much near its top. So that was great conditions on 6 meters. So you can do quite well there. For those in the Northern Hemisphere, although we're at the bottom end of the solar cycle, there is still sporadic E at this time of year. So it's a really good time to be going pedestrian mobile on either 10 or 6 meters. Where you can easily work guys, say 2,000, 2,000 kilometers away, and even with small magnetic loop antennas. So have a look at some of my videos on pedestrian mobile on 6 meters. Great fun. I'm lucky that here I'm only a short distance from the beach, so if on a nice day on summer, radio conditions are good, I'll just run out with the magnetic loop and transceiver. Okay, we'll just have a quick look at a few other things on the table. We have a small antenna coupler. It's been in previous videos. You can probably just see through the box. It's not quite transparent, but yeah. It's got switchable coil 1, 3, and 8 microhenry, RF chokes inside, and it doesn't give you quite as wide a matching range as other antenna couplers that have more coil ranges, but for something really small and portable, it's quite a nice little unit. And you might notice the board across the antenna connections. Well, that's actually 220 picofarad capacitor. There are some bands where, I think 80 meters might be one of them, where you need a bit of extra capacitance, and the variable capacitor you can see inside is just a transistor radio type. The two capacitors in them are connected in parallel. One of them is normally about 60 picofarad, the other about 160. So that gives you about 220 total, which is pretty good for most bands, but sometimes you want a little bit more, and that's why I've got the extra capacitor across the end that you can just attach. It's just mounted on a piece of printed circuit board, so you can have that in or out. Most of the time it's out, but sometimes it's handy having it. So this can operate with a end-fed wire. It could be 20 or 30 meters long on most HF bands. So that's not a bad antenna coupler for SOTA, question asked before. Little bit light on the questions, so yeah, keep asking questions, and I'll do my best to answer them. You can ask me anything. This is Peter VK3YE. Okay, we have here, this is something that is stocked by SOTA Beams in the UK, but you can get them from a lot of other suppliers. Do you sell the Voodoo antenna? Yep. For anyone not familiar with it, watch the video and particularly notice the date at the end of the video. But yeah, that was quite a magic antenna. The VUDUDX antenna. So search my video on that. I have quite a few contacts on different bands, and yeah, it's quite revolutionary. This thing here is the LCR45 peak impedance meter. You can read inductance, capacitance. It tells you reactance. There are different frequencies that I think there's a choice of 3 different frequencies that you can set to indicate reactance. I don't have any components across it, but just you can get an idea of the display. Your YouTube link on website refused me. Don't know why, but anyway, if that's a problem, just go into YouTube and search VK3YE, and you should find my channel, or youtube.com/VK3YE. But yeah, there's all sorts of interesting measurements here. Some of them a bit beyond me, some of them I wouldn't have a need to measure. But yeah, this is a handy little test instrument that I reviewed, I don't know, a couple of years ago in a video. How do we turn this thing off? There we are. And g'day to the Russian guy. Is admittance basically the opposite of impedance? Yeah, I think it is. And hello to Russian guy, Ash, we'll call you. I don't use them. I know it's used a lot in engineering, that sort of stuff. Amateurs tend not to use it much, but yeah, a bit like our return loss, I think, is the inverse of VSWR, and is used more professionally. I wonder if anyone can guess what this thing is before I tell you. While you're all... yes, you watched the video on this. G'day to Alex. No, it's not a transverter. Transverter would be a little bit more complex. But it is homemade. Yeah. Let's see if we can get better light. Yeah, it's not so good. So you can see there's a coil there, a beehive trimmer capacitor. Not quite a filter. Maybe it's a bit hard to see the other parts. Although it does have a tuned circuit in it, so you're sort of half right. But there are a couple of transistors. You might be able to see the black bits in there. 9-volt battery, of course. And there's an RF choke there. thought it was a regen 40 meters. It's not 40 meters, and it's not quite a regen, but in a way it's close. Whisper transmitter. No, not a whisper transmitter. The previous answer was almost on track. Converter. Yeah, no, it's not a converter, but it is closer than being a transmitter. It's BFO. Good guess, but no, it's not a BFO. If you look at the coils, they are. Think about the capacitor has a maximum of 25 picofarad, and you can see the coil there, which resonates with that capacitor, which means that it's you can estimate the frequency, and it's not going to be HF. The coil is too small for HF, as is the capacitor. Now, if we give some more clues, FM transmitter. Well, you're sort of in the close to the right frequency range, but yeah, no, it's not a transmitter, but it is close. The new iPhone, yeah. Well, this is the on-off switch. That's the variable capacitor, and that is a socket, and then attached here is just a short wire antenna. So you're all very close. So I'm very close to telling you the answer of it. But the answer that was most closest was regen 40 meter. It's not 40 meter, and it's not quite regen, but it is very close to being a regen. It's even better than being a regen, you could argue. But it is actually a receiver for the FM. It covers the FM broadcast band, and it's no, it's not an RBR. Reflex, 2 meter, a bit lower in frequency than 2 meter. But yes, Tim has got it right. It is a super-regen. Yeah, it covers the FM broadcast band, and it's a bit hissy when you tune, but it's surprisingly sensitive, and it powers a little pair of earphones. Yeah, I'll just see if I don't think I've got anything close at hand. Actually, let's see. I've got a cord here from somewhere. Let us see if this will work. You can hear some hum from the speaker, which is good. Well, there we are. There's a bit of hum, but so I've got it plugged into the computer speaker. And for anyone who hasn't heard a super-regen receiver, yes, this is a Q&A, and I'm Peter VK3YE. Now, just smoke it. Now, the tuning is a little bit finicky, but we'll just tune to the bottom of the band and see what we can pick up. We probably have about 20 FM stations in Melbourne. I'll just turn up the volume in case. And it's surprisingly selective. You know, there is noise between stations, and the stations are separated by about 800 kilohertz. and that has no external antenna. And yet you're right, there's no regen control. Thing is, it's a bit distorted. Sometimes it can sound clear. Like that, it's not particularly clear. But that's a bit clearer. How does it cringe? Yeah, it's self-crinching. Like everything's done in the one transistor. I have seen reference to somewhat more complicated super-regens that are that have external crinching, and I think they are a bit more versatile, and you can adjust settings more and optimize it. But yeah, this is pretty close to being the most basic super-regen receiver you can get. It's just one field effect transistor in MPF 102. Now, these can receive the aircraft band. Now, I don't know where that is, but if you go higher up, yeah, they can receive the aircraft band, but I wouldn't recommend using them up there because super-regen receivers radiate. They can cause interference. Really want to build an AM band one. Yeah, for an AM receiver, yeah, you'd make it a straight regen. Super-regens are good for VHF frequency ranges. Not so good for AM. It should be a regen. Can it receive CW? No. Although you might be able to. I think there have been ways of making them receive CW. Maybe if you introduce another signal somewhere, you might be able to get a super-regen pick up CW. But mainly they can receive AM very well, which means they'll pick up aircraft transmissions very well, but the problem is they radiate. So it's not a good idea to be using a super-regen on the aircraft band. But they can pick up AM. They can pick up wideband FM with a bit of distortion, as you just heard on the FM broadcast band. For narrowband FM, they can be a bit hissy. You might need to turn the volume a long way up and get a lot of noise. As far as the WBR, better than a regen. My understanding is the WBR is a regen. It's a funny circuit. Some people had success with it, some didn't, because it's almost like a direct short right across the antenna connection, but it's very low impedance. But yeah, some people have found them really good. Other people have had mixed views on it. I think I built one once, and it was quite, it was somewhat deafer than one that, but it was quite a nice receiver to tune and receive signals on. MFJ, make a kit for one. Yeah, finicky but interesting. Yeah. Yeah, that can be the case with regens, especially if you're trying to cover a large frequency range with them. The regen that I had that covered only a short, small frequency range, because it used a ceramic resonator, that was much less finicky. So yeah, that's the. Just thought I'd show you that. That was a little FM super-regen receiver. And this is Peter VK3YE, and if you've just turned on, this is Q&A, where you can ask me anything. We started off with portable QRP. I thought that might be topical because it's summer in some countries and they have field days and things. But yeah, you can ask me anything. And yeah, Wheatstone Bridge regenerative receiver. It had the bridge at the front end of the receiver, and I think the idea was that the incoming signal would unbalance the bridge, and then you'd be able to pick off signals from it. Ozark 4 state. QRP. So it sounds like a kit, possibly. Okay. If you've just turned on, this is VK3YE Peter, and yes, I'm live, where you can ask me anything just by typing in a question. I've written a few books about amateur radio, which you could be interested in. There's details on those on my website, vk3ye.com. And there's different titles that appeal for QRP, portable antennas. There's a dictionary that's could be handy for newcomers to amateur radio. And there's also a book, Getting Back into Amateur Radio, on people returning to the hobby. Okay, I'm experimenting with an AM regen and noticed in the next room, when I open my microwave, the AM regen gets louder. Can't see why that would be the case. Maybe there's some sort of RF noise floating around or whatever. Hand capacitance. Yeah, if you have a regen, if you have a insulated and grounded front panel, the early types used just used wood, but they put aluminium foil on the inside of the wood. Then that can reduce hand capacitance. Let's see what else we got here. Oh, what do you think of a DSO 150 you can get on eBay cheap? No idea. Never bought one, never seen one. Only thing I can suggest is having a search and doing reviews. Now this thing here is a kit that a local Australian company sell called Altronics. You might be able to get similar ones elsewhere. It's just a little audio oscillator, which can be handy for some things. You can't continuously vary the frequency. Just move it so we can properly see the display area. But you can move it up in various steps. So that could be handy for little tests and things with audio stuff. You can also set the gain 20 millivolt, 200 millivolt, 1 volt. So yeah, that's just a little piece of handy test equipment. Now K2543, now that must mean that it was a kit. So I think I actually put this together myself, probably from a kit that came from Altronics here in Australia. Okay, well, we've been going for 48 minutes. Yeah, okay, comment on those oscilloscopes. Yeah, not very good. Okay, fair enough. The price does seem almost too good to be true. Okay, we've been going for a while. If there are not any more questions, you can ask them to me now. Otherwise, we might call it a day. Thanks all for coming up and making it fun. Do you do any emergency work with the CFA or bushfire? I don't. There are. I'm actually going. Funny you should mention it, because I'm going to a later this afternoon. I'm actually going to the local fire station. I'm going to get a tour around. But yeah, no, I don't do any emergency work. There is in Victoria a body called WICEN, Wireless Institute Civil Emergency Network, where I think they're quite active in emergency communication and preparedness. But yeah, no, it's not something that I've done at all. And thanks to Research and Build for great comments and questions, and also to you, John. Rob Clark, end-fed antennas are L-match tuners better than Ballons? Yes. The problem is with a Ballon is that you've got a fixed ratio like 4:1, 9:1, or you sometimes see something like 81:1 or whatever. Whereas with an L match, you can vary both the capacitance and the inductance, and I just like that means that you can, it might be okay a Ballon, an antenna of a fixed length for one particular band or something. But when you get to more bands, I like the flexibility of varying your inductance and capacitance with an L match, and being able to get it to operate on different bands. And there's a certain satisfaction or reassurance of tuning something in properly. For length, 22 or 27 meters to avoid half waves. Yeah. There are some, the antenna couplers I've built standalone. They can cope with half wavelengths, but they are high impedance. Very high impedance of like 3,000 or 4,000 ohm if you've got an exact half wave. Some people use antenna couplers that are built into transceivers. That saves a bit of space, but they're generally limited with the impedance range that they can match over. They might only do a 3 or 4 to 1 SWR. And in those cases, you would want to avoid exact half wavelengths because so you can more easily match. I've seen charts that show you the various frequencies across one axis and lengths, antenna lengths across another. And there are certain lengths, like I think 27 meters might be one of those magic lengths that you can have moderate levels of impedance across all or most of the amateur bands. And you're not going to get much difference in performance between, say, 20 or 22 meters. But because I think I've looked at graphs and they show the impedance is like an asymptote. It goes right up to almost like infinity if you've got something exactly half wavelength. So if you can go a bit longer, then it becomes a much more moderate number that you can more easily match with a simpler antenna coupler. So if you find that your length doesn't match, then is it okay to operate 100-watt power with a magnetic loop antenna indoor while you're in the same room as the antenna? Probably not a good idea. Research and build. How precise do you need to be? If you're using, say, an L-match antenna coupler, no, not precise. It doesn't matter. You can be a meter or so out. If you're trying to match to, coax feed line or even a balun, then yes, you might need to be a bit more precise. Better than Rob Clark, better than link dipole with RG174. RG174 is thin coax. You might think it's lossy, but you should be okay provided its length is not too long. Like if it was, say, 5 or 10 meters long, then on the HF bands, you should be okay with RG174. On 2 meters, on the other hand, no, I wouldn't use it there. And a link dipole is inherently quite an efficient antenna. It's not like a vertical where you might have quite a lot of losses because of bad grounds or whatever. So, a link dipole with RG174 should be fine. The main thing is it's just the hassle of lowering the center and changing the links when you want to change bands, especially in a contest. And as far as magnetic loop indoors in the same room, probably not a good idea because of exposure. It's probably okay with 5 watts or with 100 watts if you were able to put it outside on a patio or somewhere further away from yourself or other people, then that would be safer. And what's an easy way to run coax out of the house, through the floor and out of a cool space bin? That's one possibility. Another possibility is, maybe a window, if you can fit something like, I don't know, a bit of wood or plastic or metal, some sort of insert that has a hole. And then the main problem is sealing out the cold or the heat, if that's a problem in your area. What do I do? Well, I have seen accounts of, I wouldn't be game to do it, of people drilling through glass. But yeah, I wouldn't be game to do that. Another possible, drill holes in the wall. Some walls, in fact, I'll show you right now, have vents in the top where you could put your feed line through, hopefully without making a hole. So yeah, that's one possibility. Through the floors another if you've got timber floors, not window but just under window sash. Yeah, we don't have window sashes in Australia, or hardly, but yeah, that's a possibility. Yeah, windows are mostly aluminium, timber windows in some of the older houses, so you might just be able to get away with that. Yeah, don't feel like it was a good idea, but yeah. Ladder line, yeah, sometimes thin cable can help. I was very lucky because here I have a vent that goes above the stove. You know, I've got the electric stove, but the vent lets you drop wire straight down it from the roof space. So yeah, I've been able to run the coax under the tiles and then under the roof and then straight down this cavity, and then the coax comes out. And because the lounge room is very close to the kitchen, I can run the feed line into there where the transceiver is. Have I tried a portable ZS6 BKW? I haven't. I'd imagine that it would be very similar to a G5RV. I think it's only a couple of meters shorter. It might be slightly easier to match on some frequencies than a G5RV. But if you're using a tuned feeder type dipole, an antenna coupler, a balanced antenna coupler at the bottom, the differences are going to be pretty negligible. I've used a tuned feeder dipole on 7 megahertz. That won't work very well on 80 meters. For that, a ZS6 BKW, or even better, a G5RV, a little bit longer will be better. But for 40 meters and upwards, in fact, I'd say 60 meters and 60 through to 10 meters, then a 7 megahertz dipole with tuned feeders would be fantastic with a balanced antenna coupler. I've done 1 or 2 videos using that. So yeah, well, we've had a bit of a spike. We're going down to 12, then we're up to 15 or 16. So yeah, if you've just joined, you can ask me anything about QRP and still questions. If you use my cable TV coax, plug in the wall, and then I could connect outside, yeah, I suppose you could, provided there were no other connections and you didn't need it. How about a Windham antenna? Better than a dipole? Well, okay. You'd have to tune heavy 75 ohms. Even though it's technically a 75 ohm socket, people have used 75 ohm feed line on antennas that might normally be 50 ohm, and you know the VSWR might be say 1.4 to 1, something like that, but you should be able to get away with it if it's not very critical. Yeah, now the different types of Windhams, there's I think called the Carolina Windham. Some people confuse them with off-center fed antennas. The real Windham is just a vertical single piece of wire radiator, and then it joins up to another single piece of wire, as opposed to an off-center fed dipole, which is a bit different. But yeah, I've come close to using a Windham in a recent video where I used a T antenna, except it went up 5 meters and then there was a flat top 10 meters across, but I connected it to exactly halfway along rather than I think a third of the way along like with the Windham. Yeah, Windham is basically an end-fed type of antenna. It could be an issue with RF pickup if you're using it at home, and the vertical bit which would be radiating and also picking up RF noise. Rather than having a shielded feed line, it might be a bit more prone to noise in an urban environment, and you would need a good antenna coupler at the bottom to match the Windham. But yeah, no reason why it can't operate on multiple bands, especially from a quite portable location. Yeah, they're an old style of antenna. They date from when people, and when you had valve transmitters and you just tapped the antenna on a tank coil and you probably tried to find maximum antenna current or maximum field strength, and you didn't care much about harmonic suppression. I think that was about the time the Wyndham was used. Dates from the early days of radio. Do you have personal favourite 40-80 metre CW design? As far as our favourite is, I've done a lot of construction of transceiver designs recently. Some have worked quite well on in some of my older videos, but basically anything that's I talk about this on my website. There's W7EL. That's very well regarded design. However, it does use double balance mixers. And you do need good audio gain. And the problem with having high audio gain is there's an increased chance of hum. And you have to be careful with how you orient things. And in the W7EL design, he didn't use a printed circuit board. He just stuffed all the parts in a box, so that it would have been an absolute pain if you wanted to modify or service it, and it would be difficult to reproduce it. I think he actually wrote that in his original article anyway. But yeah, for a good performing direct conversion rig, that would be good, although it is only direct conversion. If you wanted some selectivity, you could go with something with a phasing receiver. I should really build a phasing CW transceiver. That would be quite a fun project. With the hum, that can even apply if you are using batteries to power it at all. I find if hum is a problem, it's sometimes easier to use QRP rigs using an NE602. The basic RF performance won't be as good, particularly with strong signals, but you have a bit of gain in the NE602, which means that you need less audio gain, which lessens your risk of hum and problems. And they can work tolerably well. I talk about my minimum standards for QRP equipment on my website, or minimum standards for QRP projects. And basically, if you go for something that's only crystal controlled, if the receiver isn't all that good, and if it's too low output power, then it might be fun to build as a project, but not so good if you want to make random contacts. On the other hand, something like W7EL meets all those requirements and will get you contacts. We have just been going over an hour. This has been a live stream from Peter VK3YE, where we've talked about a range of topics. We started with portable operating and antennas, and we've gone into equipment, bit into equipment design. And have a great week, John, and thanks for logging in. And W7JI, have a search of that on the web. We've covered quite a range of topics. So if you've got field day in your country in a few weeks, give it a go. Get a portable antenna going, maybe using a small antenna coupler, and have a lot of fun. There's info on my website, vk3ye.com, and on this channel where there's over 700 videos. And of course, there's also my books, which you can see there. So have a great day, everyone. And it's just after 1, so I might head off and have some lunch. Thanks to you all.